right, we ready?
Mm-hmm. Hey everyone, welcome back to Quality Matters. I'm your hostess, Darci.
And Kyle.
We found out that, I guess it's the Deming Institute, has blog posts.
Well, they actually took our video with Mattress Mac and made a blog post out of it.
They did. So sometimes the blog posts are just links to other things. But I pulled one of those for us to talk about today.
Cool.
And it's about the Toyota production system.
In today's global economy, quality matters. Benjamin Franklin once quipped, "The bitterness of poor quality remains long after the sweetness of low price is forgotten." Quality Matters is here to talk about all things quality. So whether you're looking to improve your business, getting ready for an audit, or dealing with failed inspections, tune in, check us out, then get back to doing work that matters.
All right. Now, if some folks know, some folks may not know, Edward Deming is his father of quality management. We've talked about on that previous podcast. If you've not listened to him, shame on you. Go listen to all the old stuff. Shame. So, in any case, Edward Deming was, it's more detailed than this, but effectively put in charge after World War II with helping to rebuild the Japanese economy and rebuild their manufacturing and production systems. Part of the reason was they didn't want Japan to go and do what Germany had done after World War I. They kind of went bonkers, and so they wanted to avoid that happening with Japan. So that Edward Deming was
Who is they?
The U.S. federal government.
Okay.
Well, in
Where
NATO.
is Deming from? Is he from the U.S.?
Yeah.
Okay.
Yeah, and so he was put in charge of revitalizing the manufacturing system over there, and he had these just fantastic, oftentimes common sense theories about quality and quality management. And he, while he did not create the Toyota production system, his theories and teachings and philosophy are at the absolute heart of it.
Right, and I think somewhere in here, somebody says something to the effect of Toyota wouldn't be where it was without him.
Absolutely.
Absolutely. Again, I don't usually tell Kyle what we're going to talk about, maybe just the brief headline or the topic, and we kind of get into it. But this article, and I can, I've said before, I'm not a quality expert. I'm learning as I go. I know more than I did a year ago.
Yep.
And usually I can read these articles and it makes sense to me, and that's fine. And even if they don't make sense, I can kind of read between the lines and infer.
This was a little more difficult.
This one, I couldn't even read the lines. I mean, I could. It's not that the words were too hard. I just had no idea what they were saying. So I definitely had to bring Kyle in and ask him to help explain this. But it started out great. I have a lot of highlighting here. So in the 1960s, will you stop showing that? Oh, and let's show them on the back his drawing.
Process mapping.
But that was something totally unrelated to this.
Don't get me started. I'll talk.
Anyways, in the 1960s, there was a man named Frank Pipp who was an assembly plant manager for Ford Motor Company factory. So I love this idea that he had. He sent his employees out to go buy competitors' cars. So he wanted to disassemble them and reassemble them and see how they were put together.
I like it.
And so at that time, at Ford, if two parts could be put together without any tools, also known as a handy rubber mallet, they were called a snap fit. And then all the other parts required the mallet to assemble. So they were surprised to learn that one of the cars they purchased was 100% snap fit.
Fantastic.
He didn't believe it, so he told his team to take it apart, put it back together again, and they did, and they found out it was 100% snap fit. Guess who this was made by?
Toyota.
Yes, it was a Toyota truck. So then they called in their corporate people and said, to say, well, what are we going to do about this? And this was really funny. And it says, according to Pipp, everyone was very quiet until the division general manager cleared his throat and remarked, "The customer will never notice." And then everyone...
Never noticed that Ford has to tap their parts to get them to quite fit together properly.
Right. And then everyone excitedly nodded assent and exclaimed, yeah, that's right. And they all trotted off happy as clams. Because that's that culture and paradigm shift. We don't have to change anything. We can keep doing it the way we want. Okay, so I was really excited about how this blog started out, and then I quickly got confused. So then Larry Sullivan from Ford went to Japan in 1982. He was studying different quality systems in the automotive world. So
this is 20 years later. That was in the 60s, right?
Late 60s, yeah. So they're still studying it. And he says quality in itself has not been the primary motivation in Japan. Profit is the main objective.
What?
And quality methods is merely a means to improve profit.
I think we just talked about that with the Mayo Clinic.
I was about to say, if you happen to listen to our 3-part series on Mayo Clinic, they talked about that. They had other goals, benchmarks, objectives, whatever you want to call them.
Yep.
And profit is a side gig.
But here the goal was to make money. Wow, that's a novel idea. And the best way to make money is with a quality product.
Okay, so I'm not really going to go through a whole lot. Many pages don't have a whole lot of highlighting because I had no idea what they were talking about. And Kyle had to come back and read in. But one thing that they talked about is the part
versus
part of. Okay? And he talks about making something at home. When you make something at home, Kyle often builds stuff for us at home. You are the designer, the purchaser, the fabricator, the assembler, the everything. So you know exactly how it all has to go together.
And if you make an error on one part, you know exactly how much to compensate on the next part.
Right. You're quick to judge the product quality is what this says, and adjust the design, procurement, fabrication, assembly process. Okay. So he talked about, a crown molding in your house. Some of it's bad. So you got to cut it out, put it back in. You measure how long that needs to be. You draw one line and that's the cut you make.
Yep.
That's the part of mentality.
Yep.
This is going to be part of something else.
Right.
So you put it, it's going to go back in there. You measure exact. Okay. So many times in the manufacturing plants, there's a tolerance.
Right. They're making a part. Making a singular part.
And so there's a tolerance of above or below. It can be a little bit off because this person is only making this part, and then it gets sent to this person that is making this part, and then it gets sent to the assembler who has to use the mallet because there's a tolerance.
Right. And I'll give you a quick example. Like when I build stuff at home all the time, I don't have the best table saw. I don't have the best setup, right? So I know generally, and this is my own tolerance, generally speaking, I'm going to be up to 1/8 of an inch off with every single cut. Just because I don't have the best equipment, I just can't get that precise cut every time. So what I'll do is, let's say that my fear is the piece will be too long, but it can't be too short. I'll purposely try to cut it 1/8 of an inch too big, and then I'll go fit it. Nope, it needs a little bit. So then I'll just shim like the slide is a little bit off the edge. Try it again. Slide a bit off the edge. Fit it again. And it fits perfectly. And you would think I had made it perfectly, but it actually took 4 tries.
And, the problem with big production organization is they can't afford that time. You don't have time to do that. He does say that in Japan in 1950, Deming suggested they view production as a system, which is kind of what we're talking about. So tell us more about the part of.
Sure. So when you manufacture something, and the table saw example is a great example, your machine can only get so accurate, And statistically, say you're wanting to cut a piece to exactly 1 foot. Well, statistically, you might have 3% of the pieces are a little over and 5% are a little under. Well, you don't know where that piece is going to get used in the future. So that little bit over may not hurt anything. but that little bit under could be a critical problem for the next person down the line. So you know the tolerance of your machine, and as long as all of those parts come out within the tolerance of how good that machine is, you're good. But then you have all of these, you have a 2 or 3% return rate because your parts aren't any good, and you're kind of scratching your head like, these are all perfect. These are all perfect.
And, you know, the representative from Ford that said the customer will never know. No. I mean, I think they're going to know at some point.
Well, they're going to know because they're getting fewer features for the same price. Mm-hmm. Whereas Toyota could, I'm sure, offer more features even for a lower price because they didn't have to do what I do with the table saw of, I'm going to purposely cut it a little bit long because I know I can shim more off. Mm-hmm. They know that if it doesn't fit right, they can just smack it into place and get it to work perfectly. So the end product may be the same, but the cost to go into it, the time to go into it, and the value of the features that go into it are very, very different because they took good parts and try to make them a part of something else. That just didn't work out very well for them. Whereas you have to design each piece to fit with the next. Mm-hmm. Probably the single best example I ever ran into is, because I came from the gas turbine world, is you've got these blades on a gas turbine, and they've kind of got like this little, I don't know, little weird squiggly shape on the end. And a weird squiggly shape slides into a slot on the rotor so that you get all these blades lined up in a circle around it, but they fit loose. And it just boggled my mind. Like, why are these loose? They should be tighter. They should be tighter. And someone finally explained to me, it's like, well, Colin, yes, but for the fact that this turbine, when it's spinning at full velocity at high heat, the metal expands. So we have to allow so much of a gap there so that once it gets up to full speed and full temperature, it expands to fit perfectly and then it runs smoothly. Mm-hmm. Said, but when it's at low RPMs, like you can literally hear them clack, 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 clack. All the pieces are clanking and clacking together.
It's not functioning as it should be.
So, but if I were to just get those two pieces and I was told, build a blade that will fit this rotor, well, my gosh, I'd try to make it fit within 1,000th of an inch. Mm-hmm. I'm trying to build a good part. I'm not trying to build part of a system.
Okay, and then what about these interchangeable parts? It talks about Honoré Blanc. I don't know if he's from France. Uh-huh. He was first credited for conceiving of interchangeable parts. Mm-hmm. Thomas Jefferson was a U.S. ambassador to France. He liked this idea, but really, and when Kyle was reading this and talking about it, he said something about rifles and guns, and they're out on the field, and if your gun locks up or something's break, you're just hosed because and I said, well, Eli Whitney was credited for that because he designed a rifle, I think, with interchangeable parts.
So with guns for the longest time, you had a gun and it was a good gun and it was a perfectly functional gun, but the diameter of the bore might be slightly different than the diameter of the next guy's bore. And so these guys would go around with kits to make their own ammunition. And so they would melt the lead and pour it into a mold, and that mold fit their gun. Mm-hmm. Maybe it would fit someone else's gun, but it was guaranteed to fit your gun and only guaranteed to fit your gun. Mm-hmm. Maybe the pins that are in your gun, those pins were made just like I make furniture. They were made to fit that gun. And so they were maybe a little off in diameter or length or strength or all these different things. So if I'm on a battlefield and my gun is broken, I cannot grab a piece from someone else's gun to fix mine. I'm out of luck. Mm-hmm. My gun's busted and I can't use anyone else's to fix mine. Well, he said Eli Whitney came along and created these interchangeable parts so that they were made to, not only made to a tolerance, but they were made to a tolerance that matched the tolerance of the next piece. That matched the tolerance of the next piece.
So this was kind of the introduction of mass production in the United States. But I believe that Toyota in Japan doesn't necessarily agree to that, right?
Yes and no.
So it's talking about Taguchi, Junichi Taguchi. Mm-hmm. And he has this model, which, again, we can link to. And it says it brings into question the mass production belief that all parts within the range of tolerance are equally good and therefore absolutely changeable. The degree to which variation from a target dimension produces harmful effects downstream in the organization and society is a function of the steepness of the quality loss function.
So the way to look at that is Eli Whitney was the first to introduce on a large scale these interchangeable parts that are made to a tolerance. And so you could build a gun from pieces. But a gun compared to an automobile is not very complex. I mean, nowhere near the complexity required, nowhere near the number of parts required. So if you've got little problems in there, they're not going to add up a whole lot. I know I could have some, rifle enthusiasts that disagree with me on it, but I'm sorry, your rifle is not as complex as an automobile. So now you're dealing with something on the scale of an automobile with, instead of 50, 100 pieces to it, it's tens of thousands of pieces. Well, those little tolerances, they add up, they add up, they add up, they add up, they add up. So that what you mentioned here is what downstream in that process, all of a sudden, weird things are not fitting together, and you can't figure out why they're not fitting together. And it really has nothing to do with these two pieces. It has to do with the 50 that came before them.
Makes sense. Okay. I've got a couple of connections to that, but our listeners probably wouldn't be interested in them. So I'm thinking about my quilting and cutting and sewing and ironing. But anyways, so he says any deviation from a target dimension results in some degree of loss being imparted downstream.
Because again, you just don't know how they're all going to fit together. And I've run into this before is you're purchasing something from a supplier and they all give you a tolerance. And what that tolerance means, let's say it's 10% of some measure. We'll just call it, say it's got a tolerance of plus or minus 1 millimeter.
Okay.
Right? So that means that there is some statistical probability that this is going to be a millimeter bigger or a millimeter smaller than what they're telling you it is. Now, you might be like, well, this is not a very high-tech solution that I'm working with. It's not very technical, whatever. If it's got a tiny bit of wobble in there, I don't care at all. Other solutions, that could be absolutely detrimental. And so the idea behind Toyota is that they're not just going to select from good manufactured parts. They're going to manufacture a good part to be used with the next one. So they're engineered from the start to work together. So that if this one has a tendency to be over by this much, they know that the next part has to accommodate it. Whereas the typical idea with Ford was, well, we can just build a car by buying all of the parts and putting them together. It can work, but it's more of a one-off solution.
Without going too far down the rabbit hole, why did the U.S. send Deming there to Japan?
Oh, because we completely decimated their economy when we launched a couple of bombs on them.
Okay, so we felt bad about what we did?
Sort of, but see, a lot of it goes back to World War I with Germany. In World War I, Germany went bonkers. Reasons don't matter so much for this podcast. Germany went bonkers, tried to take over the world. So we as in like the collective world, just decimated Germany. And we put all these restrictions on them to try to prevent them from going crazy again. Well, that didn't really work very well, obviously. They still went bonkers and tried to take over the world again. Well, we didn't want the same thing to happen to Japan. Because the world had taken this one approach to Germany of let's minimize their production capacity, let's keep their economy low, let's put restrictions and limitations on them. So the idea with Japan was somewhat different, where we said, hey, let's try to rebuild their infrastructure. Let's rebuild their manufacturing. Let's rebuild their system so that they can enter the world as an equal player and not this totalitarian tyrant.
So I'm wondering now if that was to the detriment of our production and manufacturing facilities.
Maybe, but
or if ours had the option.
Yeah.
And
Toyota,
they found
Toyota.
it.
Yeah.
In the 1960s, they found it.
Japan had a reason to change. America didn't have a reason to change. We're on top of the world. We didn't listen to Deming.
But
we were
you're
too good.
A good organization.
Yes.
How can you make it better? We talked about that in our Mayo Clinic
but
one.
That was the problem, is we wouldn't listen to Deming, but they would. They would. They had a reason for change.
I think we kept kind of bringing this up with our Mayo Clinic series. that so many people have kind of a chip on their shoulder. Not even that, like they just don't want to change. Like, no, we're already making a profit. It's fine. But man, even if you're already good, you can still be better. And why not be better if you can?
And we talked about what the Mayo Clinic one is, you know, in any case, the trickle-down effects of the improvement to your organization can truly affect the rest of the world.
Yes.
This is another great example.
I mean, look at when they took his advice, look at how successful they are and how many studies there are of Toyota. Like the Mayo Clinic one we just did referenced their Toyota production system. This one is talking about the Toyota. Start With Why, that book talks about Toyota and the rubber mallets. They said we make it fit the first time.
You never know how same thing downstream. They've got downstream errors here, but you have the same thing with improvements across society. If you do well at your job, that has an impact, not just there, but it truly can trickle out to the rest of the world.
Right. We shouldn't worry just about the negative impacts.
Yeah.
We should consider how can we positively impact.
It is. And again, this is why I love quality management, because you can make a difference in ways that just cannot be conceived of.
So we'll link this article to the podcast so that you can read it, or this blog. This entry was by Bill Bellows from the Deming Institute. We always like to give credit where credit's due.
And I think we actually got to meet him at an ASQ conference.
Did we?
I think so.
That's interesting. I don't remember. Sorry, Bill, if we didn't meet you. All right. Thanks for listening, y'all. So when you listen to our podcast, however you listen to them, make sure you click subscribe so you'll be alerted when there's a new one out. If you need more information, you go to qmcast.com and find lots of information about us there.